All right, 4-3C. So maybe you don't like these reference triangles that we've been doing, okay? I don't know if you do or not. Do you like the old 30, 60, 90 triangle or the 45, 45, 90? They're not bad. This is another way to evaluate your trig functions at any angle. Any angle. It doesn't have to be just 0 to 90. Okay, so what we do is we're going to create something called the unit circle. So go ahead and draw a Cartesian plane.
Why do you always say that?
Because that's what it's called.
Why do you say plane?
An XY plane?
Yeah.
I could. I like Cartesian because it's named after Rene Descartes.
Was that like one of those notes that you put in when most people were
No, bless you. No, I think I learned that in my history of math class. Okay, so this is, why is that funny? I took 2 history of math classes. All right,
Nerd.
I had to. All right, so this is a unit circle, and the radius of a unit circle is 1. There's the radius is 1. And I just drew this right here, and this is to any random point. We'll call the point XY. And this angle inside here, they call T. You can call it theta, but they just call it T. And what you do is you drop a perpendicular down to the x-axis. And so that creates a triangle for you. And for this triangle, the side that is adjacent to T is what's the length of that side right there? This side right here. Oop, let me go to a different color. What's the length of that? The point up here is XY. So what's it looks like 0.5, but figure not drawn to scale. It's X. It's X. Okay? Right? If this is the point X, I go a distance of X, that's where my point is. So what would this side be over here? Yes, it would be. That would be Y. Okay, so knowing that, we're on a unit circle, we can evaluate all 6 trig functions again. So instead of R being R is now going to be 1 because we're on the unit circle.
Why does this work? Like why? Why is it so hard?
Because it's going to be a ratio. So if you have something over R, why not just make R 1 and then all the ratios are going to be the same? It's going to be easier that way.
It doesn't change like if you have like 720 degrees?
No, because the angle's still the same. It's the ratio. So like, for example, let's say that R wasn't 1. Let's say now it's 2 or whatever. Okay? The ratio, now X is twice as big and Y is twice as big. The ratios are going to still be the same. So they make it 1 to make it easier on you. All right, so here we go. Let's evaluate all of our trig functions. I don't like that there. Let me get rid of it. So let's evaluate the cosine of T. And you can do these. I mean, you know SOHCAHTOA. So the cosine of T using this triangle right here and this angle T, what would the cosine of T be? Just X. It's going to be the X value. So when I want to evaluate the cosine of that angle, I go to whatever point that is on a unit circle, and the answer is just X. All right, how about the sine of T? The sine of T would be Y. All right, what about the secant of T? Secant, remember, is the reciprocal of cosine. 1 over X, as long as X is not 0.
But it won't ever be 0, right?
It can be. X can be 0. Like right here, X is 0.
But you can still use the unit circle there?
Yep. And then cosecant of T would be 1 over Y, as long as Y is not 0. And when Y is 0, then it's undefined. You just say undefined. And then tangent, we already know what tangent is because we've done this one already. Even when we were on not a unit circle and we had just R. What was tangent? Bless you. Tangent is Y over X. And it's undefined when X is 0. And then cotangent of T is X over Y.
So that's review, right?
It's not, well, you know what? It's replacing R with 1. It's basically all the stuff that you've already done, but now R is equal to exactly 1 because we're on a 1-unit circle, a 1-unit radius circle.
Is this it? And then we just have examples?
Well, now I'm going to show you what the points are at all the 30, 60, 90, 45, all those, okay? One more thing. If you notice something here, in Chapter 5, we're going to do something called Trig Identities, where different trigs equal other stuff. Like we're going to learn that sine squared of theta plus cosine squared theta equals 1. But if you look up here, tangent of t is equal to, well, what's y? Y is sine of t. What's x? X is cosine of t. Tangent of t is sine t over cosine t. And then we're going to get into an...
I don't know. I remember saying something.
I don't know. We're going to get into an entire chapter of trig identities like that, but not yet. Not yet. Okay. Anyways, here we go. Now, if you notice, points on the unit circle are going to be x, y all the way around, and x is the cosine of t, and y is the sine of t. So on a unit circle, that's what they're equal to at those angles. Okay? So let me go ahead and tell you what the points are at all of those special angles. I don't really have A or B. It's just one thing today. Yep, it's just all just unit circle. It's pretty short too, yeah. Okay, so let's go ahead and here we go. Draw a unit circle again. Give yourself some room. Okay? And so for this unit circle, I'm going to label some points on here. Right here, this is the point 1, 0. X is 1 and y is 0. It's a unit circle, so the radius is 1, so you can see that. What would this be up here then? 0, 1, thank you. Okay, over here, this is the point, negative 1, 0, great. And down here, 0, negative 1. Okay, now let's go to some special angles. We have a special angle here of pi over 6. I'm going to do these in radians, okay? We're going to kind of get away from degrees. Okay, then we have one that splits it in half, and that angle is pi over 4. And then finally, I have this angle here, the blue one, is pi over 3. Okay, now these angles go all the way around everywhere. Like you could have one over here, for example, this one over here. If I were to draw this angle, this would be 5 pi over 6. Okay, now if I ask you what is the cosine of 5 pi over 6, all you have to do is memorize the first quadrant and you will get that point, okay? So let me tell you what all of the points are at each of these, angles here. All right, so at pi over 3 on this unit circle, and oops, they use your 30, 60, 90 triangles to find these numbers, okay? So right here, this would be x is 1/2 and y is rad 3 over 2. At pi over 4, that's the point rad 2 over 2, rad 2 over 2. And then over here, at pi over 6, x is now rad 3 over 2, and y is 1/2. There you go. And those are the 3 points that you need. Everything else comes from that. Okay, so write those 3 points down. And those are going to be the most important points that you have. Now, if you're worried about memorizing them, one time I saw this trick, and this person did this. They wrote like this. They wrote 1, 2, 3, and then going back up, 1, 2, 3, and then they just took the square root of everything, all the numerators. What's the square root of 1? 1. Square root of 2, square root of 2, square root of 3. So that's what they did to kind of memorize it. They started at the top and went 1, 2, 3, and the bottom 1, 2, 3 back up, took the square root of all the numerators. Now, what are we going to do with these? You're probably wondering. Well, we are going to evaluate, number 1, we're going to evaluate without a calculator, all of these values. So you ready? Let's do some. Let's start in quadrant 1 and get used to it, and then we'll go to different quadrants and I'll show you how to do those. So let's evaluate the cosine of pi over 3. Okay, the cosine of pi over 3. Now remember, on the unit circle, the cosine of an angle is the x value at that angle. So you go to pi over 3, and you look at the x value, and the x value at pi over 3 is 1/2. And that's it. Done. Okay, let's stay there. What's the sine of pi over 3? The sine of pi over 3, the sine on the unit circle, you go to that angle, and it's going to be the y value at that point. And what's the y value at that point? Perfect, rad 3 over 2. Okay? Tangent's going to be a little bit harder. Tangent of pi over 3 is to go to that pi over 3, go to the point on the unit circle at that angle, and tangent is the y value over the x value. So in this case, the y value is rad 3 over 2. The x value is 1/2. You're not allowed to leave fractions within fractions, so you need to fix that. Do you know how to fix that? Take the bottom, flip it, and multiply. It's just rad 3. Yep. The tangent of pi over 3 is just rad 3. All right, let's do another one. What is the sine of pi over 4? The sine of pi over 4. So you're going to go to your unit circle. Now, your unit circle, I will always give you a blank piece of paper, and you will fill it out really quickly. Okay? All you have to do is fill out those 3 points, and then you got it from there. So let's do the sine of pi over 4. Go to the angle pi over 4. Go to the y value, because that's what sine is, and you get what? Rad 2 over 2. And pi over 4 is actually really nice, because pi over 4, sine and cosine are both the same at pi over 4. So you don't have to, like, if you're worried about mixing them up. And by the way, I always think about this, because some of you guys are like, how am I going to memorize all this, right? I think of x, y is the point, and that's cosine of t or theta, whatever, it doesn't matter, sine of t. So I think it's alphabetical. X and then y, c before s. Okay?
Wait, what?
It's alphabetical.
No, I heard that part, but like, what do you mean, like the cosine and sine t?
So all these points, cosine of t is equal to x, and sine of t is the y value. So all of your points are really cosine t, sine t on the unit circle. See, okay? All right. Okay, let's do one of the points that is at one of our 90, 180, our right angles. So let's evaluate the sine of pi over 2, the cosine of pi over 2, and the tangent of pi over 2. Now you did these last night in your homework, and they were a little tricky. Well, now they're going to be so much better because the unit circle is going to make sense to you. So when you go to pi over 2, you'll go to the unit circle. Here's our angle, and you'll look at this point. On the unit circle, that is the point 0, 1. Okay, so what is the sine of pi over 2? It's 1. It's the y value. I know, it's easy to get them mixed up. Just remember they're alphabetical. X before y, c before s. And then cosine of pi over 2 is the x value there, so 0. And tangent is y over x, so tangent would be undefined. Perfect. All right, so now let's branch out. Are you ready to branch?
No.
Yes, we're ready to branch out. We're going to branch out into all the other quadrants. Now, the book actually lists all of the points for you. Whoa, that's a little zoomed in. All of the points for you, okay? So if you go over here to 4 pi over 3, we can see what the points are. I don't want you to memorize this whole thing. I want you to just memorize quadrant 1. Because look at, if I go to 4 pi over 3, isn't that the same point as pi over 3? They're the same. It's just they're both negative down here. Okay, so I'm going to show you how to evaluate. Yes, exactly. That's what it's going to, you're going to love that. I mean, I hate that, but you're going to love it. All right, so if you want to find, for example, the sine of 4 pi over 3, this is what you do. You go to your unit circle. You go up here to pi over 3, and this is the point 1/2 rad 3 over 2. You will have, a blank paper. Just fill it out really quickly so you don't have to keep doing that every time. And you just look at the reference angle, which is simply pi over 3. You'd go to pi over 3.
Can you zoom out?
Oh, yeah, I'm sorry. There you go. So reference angle is pi over 3. Huh? I didn't zoom out?
You zoomed out a lot.
Oh, too much. Okay. There we go. All right, so this right here is angle pi over 3. And I wrote down 1/2 rad 3 over 2. So my answer is going to be the y value because I'm evaluating the sine. But I'm actually in what quadrant here?
Quadrant 1.
Well, I am here, but 4 pi over 3 is a whole pi and 1/3. I'm in quadrant number 3. And in quadrant number 3, all students trust Christ. Only tangent is positive in quadrant 3, so I put a negative sign on there.
I'm sorry, how'd you figure out what quadrant it was in?
Yeah, okay, so 4 pi over 3, you have to be pretty good with fractions, so you have to think of that as an entire pi and 1/3 more.
So I just go to pi.
So you go to pi, and then you go 1/3 of a pi more.
1/3 of a quadrant?
1/3 of a pi, 1/3 of the half, the bottom half.
Okay.
Everything's in pies, so you go around a pi. All right, let's do another one. Let's figure out what the cosine of negative 7 pi over 4 is. The cosine of negative 7 pi over 4.
So that's like 2 pi minus 1.
Yeah, it is. Yeah.
So for like the half, like the points that you were giving us, so
Yeah.
it's exactly the same.
It's exactly the same in all the quadrants. They're just positive or negative depending on what quadrant they're in.
Oh.
Yep. Okay, so what I do is this. I go, all right, I know that the cosine of pi over 4 is rad 2 over 2. Now I got to figure out if it's positive or negative. Okay? And these are always going to be worth 1 point. And if you write rad 2 over 2 and you don't put a negative or like depending on what it is, I will mark you completely wrong. Like it has to be the exact number with the right sign. So where is negative 7 pi over 4? Quadrant 1. It's 1. Does anyone need an explanation on that? Yeah? So what I do is I look at it like this. Jeanette, you just did this. You went negative 8 pi over 4. That would be all the way around to 2 pi. But it's 1 short of that. So this is really the angle to there. I'm in quadrant 1. Everybody's positive in quadrant 1, so there's my answer. Don't you love the unit circle? Isn't it so much better than drawing triangles every time? I know, right? No, it's better than the periodic table. Thank you. All right, let's do, it's not your best friend anymore. Let's do the secant. We haven't done any of those yet. Let's, I love Mr. T. Let's do the secant of 5 pi over 6. Secant of 5 pi over 6. Now, nobody likes secant. Nobody likes cosecant, and nobody really likes cotangent. Secant is going to be the reciprocal of cosine, okay? So this is what I want to do. I really want to think in my head, what's the cosine of 5 pi over 6? So I go to its reference angle, which is just pi over 6, okay? And I always have my unit circle here, pi over 6. Cosine at pi over 6 is what? Yeah, it is. It's rad 3 over 2. Cosine is, okay? So now let's fix it. We got to find our answer. So a couple of things. One, we need to flip it because it's the reciprocal. So we're going to go 2 over rad 3. But what quadrant am I in? 2. 5 pi over 6 is 1/6 short of a full pi. 6 pi over 6 is a full pi. So 5 pi over 6 is just 1 short. So I'm in quadrant 2, and cosine is negative in quadrant 2. Now, the book's fine with you leaving that. If you want to rationalize, that's fine. I'm not making you do that this year. You want to try one? Yes. Okay. Yeah. Reciprocal, yep. So you got to do this. You got to know it's the reciprocal, and you got to figure out which sign it's in by which quadrant it's in. How about the cosecant of 5 pi over 3? Try that one. Let's see if you can get that one by yourself, okay? We're going to go to our reference angle of pi over 3. You don't have to draw the thing every single time. I just want to show you where we're at. Pi over 3 is up here. This is the point 1/2 rad 3 over 2. So I'm thinking rad 3 over 2. Okay, but that's not right. I got to do a couple of things. Number 1, it's cosecant, so I got to flip that. Okay, so 2 over rad 3. And then I have to figure out what quadrant am I in? What quadrant is 5 pi over 3 in? 4. It is. It's in 4. 5 pi over 3 is almost 6 pi over 3, which is 2 pi around, but it's 1 short of that. So you're actually, this angle over here, you're in quadrant 4, and in quadrant 4, it's negative. Anybody get that? Good. Bless you, Nick. About, I don't know, like 12 people got that. It's not very good yet. Okay. All right, so let's get that